Okay, let's do this. So, a meteorologist believes that there is a relationship between the daily mean wind speed and the daily mean temperature. And we've got 9 consecutive days taken from a UK town. Okay, and we've got the PMCC. It's given as R is equal to 0.609. Explain why a linear regression model based on these data is unreliable on a day measuring 24 degrees Celsius. Well, you can see here that all of the data is nowhere near 24 degrees. So we would be extrapolating the data out in order to cater for this 24 degrees here. So we can't do that. Well, I mean, you could, but it's just always unreliable. So we're going to write it requires extrapolation. So will be unreliable. Yeah, and that should do the job. Okay, part B. State what is measured by the product moment correlation coefficient. Well, that is the most important word here is linear. So it's a linear association or correlation. I'm just going to say association because you shouldn't really. But you can say linear correlation. It's fine. Between, and in this case, it's between the two variables W and T. Okay, so we need to do a hypothesis test then at 5% about, and this is the most important bit here, whether it is greater than 0 or not. Okay, so we do H0, rho is equal to 0, and then we do H1, rho is greater than 0. And then we need to go to our formula book to find the critical value. And here we have it. Now we are measuring at 5% significance level, and there are 9 bits of data to pick from. So we do 5% level, and 9 is the sample size. So here is our critical value. So we say critical value is equal to 0.5822. Perfect. Right, get rid of that. You can go as well, you can go as well, you can go as well. So we need to compare that to the PMCC of the data, which was, as stated, 0.609. So we say 0.609 is greater than this critical value. And that means that it is correlated, or at least it appears to be correlated, because it beats the threshold. So we can say reject H0, and then we can say that, and it's always, you don't say that it definitely is for certain, you just say there is evidence to suggest that you can say that the PMCC is greater than 0. Is greater than, or really you should be saying that the population PMCC is greater than 0. But in fact, I'm not going to say that anyway. I'm always going to try and link the variables. What I'm going to say is there is evidence to suggest that there is a positive correlation between W and T. Perfect. That should do the job. Okay, then part D. It says, using your knowledge of the large data set, suggest, giving your reason, the location that give rise to... Oh, I missed out this line, sorry. You've got a different location, and this time round we have got the temperature is much warmer. That highlighter is not a very good one, is it? Yeah, the temperature is much warmer than what it was before, because we said that there was like no one anywhere near 24 degrees. So the fact that the average temperature is 27 means it's a very hot place. Now, it's the same 7 days, so it is in July, and clearly it's not going to be in the UK. Because that's too hot. given that the rest of the UK, or at least a certain place in the UK, is not that hot. So it's going to either be somewhere abroad, so it's like Beijing, Perth, or Jacksonville. It's going to be in the northern hemisphere because it can't be Perth because that will be in the southern hemisphere where it will be winter, so it won't be that hot. So it's either Jacksonville or Beijing. Now, it's not a lot of wind speed, so it's probably not by the coast. I think Jacksonville's in Florida, which is kind of by the coast. So we're going to go with Beijing. So I think, does it say give reason? Yeah, so it says given reason. So we're going to say Beijing as it's overseas as the higher temperature suggests. And we can say that it is what did I just say? So northern hemisphere as it's summertime, and we can say not by the coast as low wind speed. I mean, large data set, yay! Question 2, central tendency and variation. So we've got a frequency table here, and it says estimate by linear interpolation the value of the median. So what we're going to do is we're just going to start adding up cumulatively. So 5. And then add 16 is 21. And what we want to find is the halfway points. We want to find where the 30-second person is. And then add on 14 and we get 35. So that we know from 21 to 35, so the 21st to the 35th person is going to be in this group. So this is the group of the median. Because the 30-second person is definitely going to be in there. Okay, so then what I do is draw a little number line like this, and put 2 ends, one at each end like that. And so this interval is tempted to put 21 here, but it doesn't actually start at 21, just because of the way that they are written down here. It actually starts at 20.5 because that's the smallest number which will round into this interval. And it's going to go all the way to 25.5. Okay, now in terms of the number of people, so the interval starts at 21 and ends at 35. And what we're looking for is the 32nd person, and that is going to be our Q2 or the median. Okay, so what we can say is that Q2 minus 20.5, so that will be this gap here, as a fraction of the whole interval. So divide by the whole interval, which will be 25.5 minus 20.5. Now that fraction should be exactly the same as this, which is that gap there, which will be 32 minus 21 over the whole interval, which will be this gap here, and that will be 35 minus 21. Okay, great. So we can just simplify this now and then solve for Q2. So along the bottom we've got 5. And over here we have 32 minus 21, and that needs to be then divided by 35 minus 21, like so. Okay, it gives us 11 over 14. Okay, so let's times that by 5 to clear that denominator, and then what we'll do is we'll add on 20.5, and that will give us our median. Perfect. So we're going to say that Q2 is approximately equal to 24.4. Perfect. Okay. So that's part A. Now let's move on to part B. It's asking us to work out the mean and the standard deviation, and we've got this collection of values here. So we're told that to find x bar, the mean, then we take the sum of all the data over the number of bits of data. So that will be 1528.5 all over 64, I believe, was the total frequency, and it says it up here, yes, of course, 64. Okay, great. So we can put that into our calculators and hopefully get our answer, which will be 23.88. Let's go with that. And then the standard deviation. So we need the formula for the standard deviation, which is the sum of the x squareds over n minus the sum of the x's over n squared, and then all square rooted. Okay, perfect. So that is going to be the square root of 423331.75 over 64, and then minus this 23.88 squared, like so. Okay, so we'll do square root, and then we'll do 423331.75 over 64, and then we'll do minus the previous answer squared. Perfect. So we get 9.54. And that is good to go. And onwards to probability. Lovely. Okay, so we've been asked to put all this information onto a Venn diagram. But the first thing I'm going to do is I'm going to use the lovely formula, which is that the union is equal to A plus B minus the intersection. Okay, so that 7 tenths is equal to 3/5 plus 5/8 minus the intersection. So this will allow us to solve for the intersection, which is going to be very, very helpful. Okay, so on the calculator then, we're going to do just rearranging this. It'd be 3/5 plus 5/8 and then minus 7 tenths. Okay, perfect. So that gives us the intersection. Because when you're drawing a Venn diagram, most of the time it's useful to start in the center. Okay, so we've got that and we've got this. Okay, and we know that the intersection is like so. We've got to label the sides, the circles A and B. Okay, so we know the probability of A is 3/5. So if we do 3/5 and we take away the intersection, then that leaves with what's left over just for A only. And we also know that B was 5/8. So if we have that and we take away the intersection, then we have what is in B only, which is 1/10. And then the outside is everything which is not in the union, and we were told that the union was 0.7, so that leaves 3/10 on the outside. Perfect. Okay, now it says determine showing all the relevant working whether A and B are statistically independent. Well, as we know, if A and B are statistically independent, then A multiplied by B should equal the probability of the intersection. Okay, so A was 3/5, B was 5/8, and this gives us 3/8. And that does not equal the intersection of 21/40, so therefore they are not independent. Perfect. I write here for independence. That's what we're looking for. But it didn't happen, alas. Okay, now we've got another event, C, such that A union C is equal to 7/10, and the probability of C given A is equal to 1/3. Determine the probability of A given C. Okay, well, let's start with this conditional probability part and write out the formula for the conditional probability of C given A. Okay, so the probability of C given A is equal to the probability of A and C happening divided by what's given, which is the probability of A. And we're told that that's equal to 1/3, I believe. Yes, 1/3. Okay, great. And we know the probability of A, so therefore we can say the probability of the intersection, which is always helpful to find, is going to equal 1/3 multiplied by the probability of A, which we knew was 3/5. So this gives us just 1/5. Okay, now I think we are ready that we can draw a Venn diagram for A and C. Given that now we know the intersection of A and C is 1/5, so this might help us get a grasp on what's going on here. Okay, what else do we know? Well, we know A is 3/5 from before, so therefore this must be 2/5 in order to make 3/5 in total for A. And we know, what else do we know? We know the union is 7/10. Okay, great. So we can therefore do that 7/10 minus these two is going to give us what's left over for C on its own, which gives us 1/10 that needs to go in there. And again, if 7/10 is the union, then it means that 3/10 is on the outside. Okay. So we've got our Venn diagram for A and C, so we should be able to answer any question here. So the question is A given C. Okay. So the probability that A given C by the formula is A intersection C over the probability of what's given, which is C. Okay, now we know the intersection is 1/5, and the probability of C we know is 1/5 plus 1/10 from this Venn diagram. Okay, so that can just go on our calculator now. So we've got 1/5 on top, and we've got 1/5 plus 1/10. Perfect. So we get 2/3. Okay. Is there more? I think there's a little bit more. And they're asking for the probability of the intersection complement. Well, I think we know the probability of the intersection, so therefore the probability of the intersection's complement should be relatively straightforward, because the probability of the intersection complement is equal to 1 minus the probability of the intersection, which is 1 minus the probability of 1/5, so that is 4/5. Lovely. Okay, question number 4. We've got a biased tetrahedral die with faces 0, 1, 2 and 3. The die is rolled and the number is recorded, fine, and there's the distribution. Okay, so discrete random variables. Lots of people don't like this topic. They can be quite tricky questions like in 2023. Let's do it. Okay, now if x is equal to 3, then then the final score is free. Okay, so if you roll a free straight away, then your final score is free. But if you don't roll a free, then the die is rolled again, and your final score is the sum of the two numbers. Okay, the random variable t is the final score. Okay, so the probability that we get a 2. So to get a 2, we have to have rolled the dice twice, because the game ends only in the first go if you roll a 3, and you get the score of 3. So to roll a 2, then we're going to need x to be 0, and then after that x is equal to 2. That will work. Or we could have rolled a 2 straight away, and then after that x is equal to 0. Or we could have rolled a 1 followed by a 1. Okay, so notice how for 0 and 2, there's 2 ways of it happening. Get 0 first followed by 2, or you get 2 first followed by a 0. Whereas for 1, 1, there's just one way of it happening. It's just 1 followed by 1. Okay, now each of these probabilities happen to be exactly the same. It's 1/6 times by 1/6. So it's just this times by this, and just this times by this, then add all those 3 together. So that will be 3 out of 36, that's 1/12. Okay, great. Next, then, the probability of getting a 3. Okay, so how do we get a 3? Well, what we can do is we can just roll a 3 straight away, like a boss, just bosh, there you go, have that 3, and then we finish the game. Or, we could have started off by rolling a 0, and then afterwards we roll a 3. Or we could have rolled a 1 followed by a 2. Or we could have rolled a 2 followed by a 1. And I think that is it. Those are the only ways that you can win, or get a 3, sorry. Okay, so the chance of you just rolling a 3 straight off the bat is a half. So the first probability is a half. And then a 0 is 1/6, but followed by a 3, that will be a half, so it'll be 1/6 times by a half. A 1 followed by a 2 is a 6 times a 6. And a 2 followed by a 1 is again a 6 times by a 6. Okay, so that will be a half plus 6 times a half is a 12. Plus looks like 2 times a 6 times a 6 is a 36. Okay, so 23 over 36. When we add those up, and that is the probability of getting a 3. Perfect. Okay, right, on to the next part, part C, and it says that given that the dice is rolled twice, find the probability that the final score is a 3. Okay, so we are looking for the final score is equal to 3, given that it is rolled twice. Okay, so using the conditional probability formula, this means we need to find the probability that t is equal to 3 intersection with rolled twice, and then all divided by the probability of rolled twice. Okay, so how can we get a 3 and have it roll twice. So the ways that we can do this, the ways that we can get a free and have been rolled twice is this, or this would work, or this would work. So those are all the ways that we are going to get a free, and we would have had to have rolled twice to have got it. Okay, so let's just let's work that out. In fact, we kind of have those probabilities already because we've got this one, and this one. So that goes on the top of our fraction. So we're going to have 1/6 times by a half, which represents getting a 0, then a 3. And then we're going to have 1/6 times by 1/6, which represents getting a 1, then a 2. And then 1/6 times 1/6, which represents getting a 2, then a 1. Okay, now that's all over the probability of having rolled twice. Now, how do we know that we're going to roll twice? Well, in fact, sometimes it's easier to figure out what the opposite of that would be, and the opposite of that would be just rolling once. And the only way that we can roll once is if we get a free straight away, which is the chance of a half. So the probability of not rolling once, i.e. rolling twice, is 1 minus the chance of rolling once, which is a half. So it's 1 minus a half. Okay, so we can put this into our calculator. And I'm just going to do the top line first. I'm not sure why, but I've just started doing it, so whatever. So it was a 12th, and then it was 1 over 6 times 6, which is 1 over 36. Add 1 over 36. Okay, so that's the top line. And then the bottom line is clearly just 1/2. So divide that by a half, and that gives us 5 over 18 for our final answer. Perfect. Okay, binomial, normal approx, and hypothesis test. Talk about an all-in-one. Okay, the records in a dentist's surgery show that 15% of the patients that make an appointment fail to turn up. In a day with 15 appointments, determine the probability. Okay, so the fact that there's 15 appointments, that's a fixed number of trials. So instantly that is telling me binomial. So binomial, 15 fixed trials, and the chance of success, in this case someone not turning up, is 0.15. Now, what do we want? We want exactly 2 patients not to turn up. So probability that x is equal to exactly 2. So we'll just go to our calculator and we'll go to distribution, and we want, in this case, binomial PD, because we want just one exact value of 2. There are 15 trials, and 0.15 is the probability, and that gives us 0.2856, and I'd always give probabilities to 4 decimal places. Nice. Okay, now what do we want next? Okay, let's just do it here. We want at least 2 patients failed to turn up. So that's the probability that x is greater than or equal to 2, because that's at least 2. So 2 is the smallest it can be, which is greater than or equal to 2, which is 1 minus the probability that x is less than or equal to 1. Because we're taking away 1 and 0. Those are the only options which don't work. If you are 2 or more, then you need to take away 1 or 0. Okay, so on our calculator we'll go to distribution. Again, this time we'll go to binomial CD. We do variable, and we're going to do 1, 15 and 0.5. 0.15 is not going to change. And we're going to take that value, and we're then going to do 1 minus it. for a final answer of 0.6814. Okay, perfect. Okay, next part. So we are using a distributional approximation, which is the normal approximation, to find the probability that in a month with 400 appointments, more than 45, but at most 65 patients fail to turn up. Okay, so first off, the binomial approximation. So let's write out exactly what the binomial distribution that we're trying to approximate is. And that's 400 appointments with a probability of 0.15. Okay, now in order for us to approximate, we need to work out the mean, which is NP, which is 400 trials multiplied by a probability of 0.15, and that gives, so 400 times by 0.15 gives us 60. And then what we need to work out is the variance, which is NP 1 minus P. So the NP is 60, and then we times it by 1 minus the probability, which is 0.85, because the probability of 0.15. So we just times that by 0.85, and we get 51. Okay, so that will then allow us to approximate using a normal distribution with mean 60 and variance 51. Okay, great. Now let's just remind ourselves what probability we need to work out. So more than 45, but at most 65. So that is the probability of more than 45. So we need more than 45. But not equal to 45, it has to be more. But at most 65 means that we are allowed to have 65, but no more. So less than or equal to 65. So that's what we need to approximate. So the first thing I'll do is I'll write this in terms of less than or equal to signs. So this 45, x needs to be greater than 45, which means that actually the lowest value it can actually equal is 46. Okay, now this is going to make it easier for us to use what's called the continuity correction, because when you go from a binomial to a normal, it's no longer discrete. So essentially you can use like decimal values. So we've got to think about what could round to these values. So we're actually going to say it's the probability 4.5 is less 45.5, because that's the lowest we can go while still rounding to 46. And then that's less than 65.5, because that's the highest we can go while still rounding to 65. Whoops, and I should have put a y in the middle because we're now doing it in terms of y. Okay, and these things are approximately equal. Perfect. So we're just going to go to our calculator now and let it do the work. So we want, what do we want? Normal CD, yeah. We need to be between 45.5 and 65.5. The standard deviation is the square root of the variance. Always remember to be careful of that. And then the mean is 60. Okay, perfect. So we get our answer of 0.7582. And that is normal approximation in a nutshell. Okay, now the surgery administrator feels that the percentage of patients that make an appointment and fail to turn up is likely to change in the future. Okay, so change, that means that we're looking at a two-tailed test. It's not saying it's going up or down, it's just saying it's changing. Okay, fine. It requires to find whether the proportion of patients that fail to turn up is different from 15%, okay, by monitoring the next 20 appointments. Okay, that's also important. Determine the critical region for this test. Okay, So we've now got a new distribution, let's call it W or something. And this will be binomially distributed because there's a fixed number of trials of 20. And we're going to assume that the proportion actually stays exactly as it was before. And then what we're going to do is we're going to say that H0 is that the probability, again, stays the same. Whereas H1, we're saying the probability is different. Okay. And now what we need to do is we need to find the critical region. Now, to be honest, I always think just spamming answers is the easiest way of doing this. It's a two-tailed test, so we've got to go lower tail and upper tail. Some people like to use the list, but personally, I just think just spamming is the way that I've always done it. So let's try x is less than or equal to 2. And let's put the number in, so 20, and probability of 0.15. Now, you may ask, why did I pick 2? Well, what I do know is that the expected value is just NP, which is 20 times 0.15, which is, what, 3? So, yeah, you'd expect to have 3 people not turn up if this was true, if it was 0.15. So let's just go with 2. I think it would be too high, but whatever. Okay, yeah, it's massively too high, so 40%. So we're looking for something which is less than 5%. Are we looking for less than 5%? That's a good point. 10% is the significance level. It's a two-tailed test, so we have to half it. So the sig level is 5% in each tail. Okay, so if we try 1 now, that's again, it's going to be too high, 17%. Fine, that's too high. Well, let's just try 0 then, perhaps. Okay, lovely. So the probability that x equals 0 is 0.0387, or 8. And this is less than 5%, so therefore the critical region on the lower tail is 0. Okay, now finding the critical region on the upper tail is slightly more tricky, because remember, if we want to work out the probability, let's say x is greater than or equal to 6 perhaps, then that is 1 minus the probability that x is less than or equal to 5. So what we would have to do is we'd have to go for 5. So therefore this is going to be 1 minus 0.933, and that is going to be about 6%, isn't it? So when we go back over here and we do 1 minus the answer, yeah, it's about 6.7%, so that is too high. But I suspect the next one is going to be good. And then why did I pick 6? Well, again, the expectation is 3. 0 was in the critical region, so we're looking like the same distance the other side of 3 would be 6, so that's why I picked 6. A little bit of guesswork. I know there are other ways of doing it, but this is just the way I've always done it, and I think it's probably the quickest way. Whoops, not if you're chatting too much and not concentrating though. Right, so we need less than or equal to 6. So we say that x is 6, 20 trials, 0.15. Okay, we'll take that and we'll do 1 minus it, and that will be less than 5%. 1 minus answer, perfect. 0.219, no, 0.0219, and that is less than 5%. Okay, perfect. So then let's define the critical region. So we'll say the critical region is the set, let's go with x such that x equals 0, union x such that x is greater than or equal to 7. Perfect. That should do the job. Okay. Question 6, normal distribution. We've got bottles of olive oil in millilitres produced by a small factory are normally distributed with mean M and standard deviation 5. So we don't know the mean, so we're going to be using the standardized Z distribution to work out the mean. And what we need is one bit of information in order to find one unknown, and that is that this percentage of bottles contain more than 994. So I would always recommend for questions like this is to draw the distribution. So draw the bell curve like so, and then I need to draw another one as well that's going to match this one. Okay, so I'm going to draw another one here like so. Maybe a bit of overkill, but hey, maybe I just like drawing normal distribution diagrams. Okay, so we want more than 994, and 97.5% will be more than that. So it's going to be this number here. It's going to be about over here somewhere, such that a lot, 97.5%, is more than that number there, 994. So it's definitely going to be right over to the left, such that this area is 97.5%. So of course this area to the left will be 1 minus that, so that will be 2.5%. Okay, now this is the Z distribution. We don't know the mu, but we do know the standard deviation is 5, so the variance is 5 squared. And then we're going to look at the Z distribution, which is normally distributed 0, 1. And we're going to match it up, just like so, and we're going to find this Z value. And what we know about that Z value is that the area to the left of it is exactly the same as in the X distribution, so that is 2.5% to the left. So let's go into our calculator and do distribution, inverse normal. We want 0.025 area, and remember the area is always to the left on this particular calculator. And here the standard deviation is 1 and the mean is 0. Perfect. Okay, so that gives us a Z value here of minus 1.96 when rounded. Okay, now the formula that links these two distributions is Z is equal to X minus mu over sigma. So the Z value was this, the X value was this, the mean we don't know, and the standard deviation was 5. Okay, great, so we could just rearrange this for the mean. So how are we going to do that? So we're going to take this value and we're going to times it by 5, and then we're going to minus 994, and then that will give us minus mu, so we're just going to times that by minus 1. Okay, so just solving that equation, and we get 1003.8 as our value of mu. Okay. Now it says, using the value of mu found in part A, determine the probability that a bottle picked at random will contain less than 992. Okay, not a problem. Right, I better practice what I preach, and for every normal distribution question, I'm always going to draw a bell curve. Now, we know that the mean, we've just worked it out, is 1003.8. And we want less than 992, so that's going to be on this side, and less than means that we're going to the left of it, like so. So we can just say the probability that X is less than 992 is going to equal, well, we should go to our calculator now to do that calculation. So normal CD, lower is just a really negative number. The upper limit is 992. The standard deviation was 5 and the mean was 1003.8. Okay, small probability of that. So we've got 0.00 and then 914 should do the job. Okay, perfect. Okay, now it says that an inspector visits the factory and selects a bottle at random. If the bottle contains less than 992, the factory will be fined. Oh no. Given that the factory got fined, determine the probability that the bottle the inspector examined contained less than 990. Okay, so that, again, this is such a critical word in a stats exam, given. It means that we're going to use the conditional probability formula. Okay, so let's grab some space. And then for part C. So the probability that the factory got fined, and then that's what's given. So the probability that X is less than 990 given the we got fined. Okay, so using the formula, that's going to be the probability of X being less than 990 intersection with getting fined, so these two things happening together, all over what was given, which is the probability that we got fined. Okay, so let's think about this logically. So how can we be less than 990 and get fined? Well, the only way that can possibly happen is just if you're less than 990, because you have to be less than 990 and you need to get fined, but if you are less than 990 you are going to get fined, so it has to be just the probability that we are less than 990. Okay, and then over the probability of being fined, well, we know that that limit is 992. Yeah, because that's when you get fined. Okay, so X is less than 992. Okay, so we already have that probability on the bottom from last time round. It was equal to this. So what I might do on my calculator is I might go store in A. Okay, and then what I might do is go to distribution, normal CD, and this time we want to know the chance of being less than 990. Same standard deviation, same mean, and that gives us 0.00289. So I'm going to go back over here and I'm going to do the answer divided by A, which is the one which I saved from previous, to get this as my final answer of 0.3163. Perfect. Okay, normal hypothesis test, and we've got the heights of male students in a college are thought to be normally distributed with mean 1.75 and standard deviation 6. Then the heights of 4 males are sampled, and they have a height of, on average, 180. 180! Okay, determine at the 5% significance whether or not the mean height is greater than 175. Okay, so hypothesis test, of course, we need to start with H0, and that is that the mean is what we believe it to be across the population, and that is 175. And then we need to do that H1 is what we're claiming, and that is that the mean is greater than 175. Okay, now we have a sample in order to test this, so we need to denote that as the sample distribution. We're going to assume that H0 is true, but what we do need to do, just something you need to remember, is that you have to divide the variance by the sample size. Or some people just go straight to the standard deviation being of being the old standard deviation over root n. but it's the same thing. I just divide the variance by 4 in this sample size, n, and then afterwards just square root that to get the standard deviation. Okay, we've done a test. There was 4 students and they had a height of 180 on average. So we need to check how likely that was to happen. So we're going to do the sample mean probability needs to be greater than 180. Because we're not only testing whether or not 180 is likely to happen, but also anything which also strengthens the claim. So being greater than 180 will also strengthen the claim that the mean has actually changed and it is actually higher than 175. If in doubt, you just always, the probability direction is always going to be the same as the alternative hypothesis. Okay, so what is that? We need to work that out. So we're going to go to the distribution. We're going to go to normal CD. The lower is 180. The upper is just a large number. And then the standard deviation is the square root of 6 squared divided by the sample size, and the mean, which we're assuming to be true, is 175. Okay, and we get 0.04779, which is less than the 5% significance level. So this means that this event of getting 4 male students, measuring their heights, giving them a mean of 180 is an unlikely event to happen, given that we're assuming that the mean is actually 175. So because this is unlikely to happen, we are a bit suspicious. We say, what's going on here? Perhaps, in fact, H0 is not true. What we assumed is not true. And in fact, maybe the mean is greater across the population because this sample is so unlikely to happen with the assumed mean of 175. So all in all, we just say reject H0. We say there is evidence to suggest the mean height, always define the variable. Again, I'll make sure I'd write everything down. I wouldn't take any shortcuts in an exam. The mean height of male students in this college is greater than 175. Perfect. Okay, question 8, and we've made it to mechanics. Let's go. What do you prefer? Do you prefer stats or mechanics? Let me know in the comments. I like both, but I do find doing mechanics questions just slightly easier. Yes, okay. A car travelling along a straight road takes 170 seconds to travel between 2 sets of traffic lights, A and B, which are 2,125 meters apart. The car starts from rest, okay, and it moves with constant acceleration until it reaches a speed of 17 meters per second. I should be highlighting all these key bits of information. And then the car maintains this speed before moving with a constant deceleration coming to rest at B. This is important that the magnitude of deceleration is twice the magnitude of the acceleration. Sketch in the space below the speed time graph. Okay, so I would love to. So we're going to start here. We're going to start here. We're going to call this speed. And we're going to call this time. And we are going to constant acceleration up to a speed of 17. So constant acceleration means straight line. So it says the gradient represents the acceleration on the velocity time graph. And then it's going to go, it's going to maintain that speed. So a horizontal line. And then it's going to deaccelerate, but it's going to have twice the deacceleration. So that means that the steepness of the line is going to be twice that of the come on, just draw me a straight line. What is your problem? It's going to be twice as much. So that would be the same magnitude of acceleration and deceleration, but we're going to make it steeper like so. So it's going to be twice as steep. So it's just a sketch, but you have to show that it's definitely steeper than the acceleration part. Okay, great. Now, what else can we label? So we've got to label as much as possible. We've got the 17. We know it starts at rest, and we know also that it's going to take 170 seconds to do the whole journey. And then we can also, I guess we don't need to, but 2,125 will be the area under the curve, because that will be the distance travelled. Not curve, straight lines. Okay. That's good. Now on to part B. It says find the de-acceleration of the car. So what we do know is this trapezium has got an area of 2125. Now the formula for trapezium is a half times the two parallel sides. So this side up here and this side down here. So the base is 170, and let's call this side up here T. And then times by the gap between the two parallel sides, or the height of the trapezium, which is going to be 17. Okay, great. So we can solve for t to work out that that height of that time across the top, which should be useful, I suspect. Okay, so 2125. We're going to times it by 2 to get rid of the half. We're going to divide it by 17 to get rid of the 17. And then we're going to minus the 170 in the bracket, and that's going to give us t. T is 80. Perfect. Okay. So that is 80. Now what do we need actually? We need to find the de-acceleration of the car. So we need to figure out the gradient of this part of the journey. So if I just draw a little dotted line in here like this, and then if I draw another dotted line in here, now obviously we know the height is 17 of this triangle. Now the base down the bottom we don't know, let's call it x. But because the acceleration is, or the de-acceleration is twice the acceleration, it means that this down the bottom is 2x, because it's going to take twice as long for the velocity to change from 0 to 17 as it does here from changing from 17 to 0, because the acceleration is twice. Okay, and we also know that in here is 80, because obviously that's 80, so this is 80 across from here to here. So let's set up an equation for that base. So 170 is the whole base, and that's equal to 3x's plus the 80 in the middle. So that tells us that 3x is equal to 90, so x is equal to 30. Okay, great. So now we should be able to work out the de-acceleration. So the de-acceleration is going to equal the change in the velocity, which is 17, over the change in the time, which is 30. We could, I don't think we're going to put a minus in there because we've just stated it as de-acceleration. So we're just going to leave it as 17 over 30. We actually are going to put the units in though, as good habits, which is meters per second to the -2. Okay, constant acceleration and vectors. So for constant acceleration questions, it's not like variable where we do integration and differentiation. We tend just to use SUVATs in order to get to our answer. Okay, so we have been told that there is an acceleration in vector form. We've also been told the initial velocity and the final velocity. And then we're told the magnitude of the acceleration. Find C and D. Okay, so ideally we need a formula which is going to link acceleration and the initial velocity and the final velocity. And We've got no information about the distance travelled, so the suvat we're going to look at is v is equal to u plus at. Okay, so if we just substitute into here, now the velocity, final velocity is 2I plus 9j. The initial velocity is minus 3I minus 3j plus at. Okay, so moving that all to one side, so adding the 3i and then adding the 3j is going to give us this, like so. Okay, now what we have is we have on the left hand side a vector. This is in vector form, component vector form. And then on the right hand side we've got the acceleration, which we could write in vector form, but we don't know c or d. But we do know its magnitude, so that's a scalar quantity. And then t is time. Again, that is a scalar quantity. We can't write that in vector form. So what would be helpful is if we can have all of our information here in terms of scalars. So let's convert this vector into the magnitude. So what is the magnitude of this vector? Well, we'll do that by squaring the components, adding them together, and then taking the square root. So 5 squared plus 12 squared is 169. Square rooted gives us 13. Now we know that the magnitude of A is 2.6. So that will tell us the time that it's taken in order for us to do this motion. Okay, so now we can go back up here to when we were last in vector form, because we do want the acceleration in vector form. And we can write 5i plus 12j is equal to a, which we'll put into vector form, multiplied by t, which is 5. So a then is obviously equal to this vector divided by 5, which is going to be 1i plus 12 over 5 is 2.4j. So now we can say that c is equal to 1 and d is equal to 2.4. Okay, great. Okay, variable acceleration this time, and we have so a formula here, and we can, why is it variable acceleration? Well, you can see here that the velocity is in terms of t. So when we differentiate this to find the acceleration, it's also going to be in terms of t, which means it varies as time changes. So the first part of the question does say find the magnitude of the acceleration. So to find the acceleration, we need to do dv by dt. So differentiating 27 first, that goes to 0. Minus 3t squared goes to minus 6t. And that's all of the i's taken care of. And then over here, 8 goes to 0, minus 3t cubed goes to minus 3t squared, and that's the j's taken care of. Okay, so let's just write that a bit neater. Don't need the brackets, so we can write it like this. And now what we can do is we've been asked to find it actually at the instant when it's moving in the vector I. So if it's moving in the I direction, it's going along like this, which means it has no vertical velocity. It's just literally going straight to the right, so or to the left, but it's going in the horizontal direction. So that means that the velocity in the j direction is equal to 0. So the velocity in the j is equal to 0, and the velocity in the j is this, which is 8 minus t cubed. So therefore t cubed is equal to 8, so t is equal to 2. Okay, great. So now we just need to work out the acceleration when t is equal to 2. So it's minus 6 times by 2i minus 3 times by 2 squared j. So that is minus 12i, and that is minus 12j. It's asked for the magnitude of the acceleration, so we need to take the components and square them, add them together, and then take the square root, which will give us 12 root 2, and that will be meters per second to the minus 2. Perfect. Okay, now part B is asked to find the position vector. So velocity we differentiate to get the acceleration, but if we want to go to the position we need to integrate. So it's like a ladder. I remember it as PVA, like Patrick Van Aanholt. Don't ask me why. And then we differentiate down, we integrate up. So if we want to find the position, then we need to integrate the velocity. Okay, so that was part A, and this is part B. The position, R, is the integral of the velocity with respect to time. So that's the integral of, and the velocity equation was as such. Just grab it there and bring it down here. So we're going to integrate that. Okay, so when integrating this, so 27 is going to integrate to 27t. T squared, we're going to up the power to t cubed, divide by the new power, it's going to cancel out that 3, and that is I. And then over here, we're going to have 8 is going to integrate to 8t. The t cubed is going to go up to t to the 4, divide by the new power, and then of course we can't forget the constant of integration, and that is equal to r. And then how are we going to find c? Well, we're going to need some sort of condition. We need to be told a position, and annoyingly it's not when t equals 0, because it makes it much easier when t is 0. Instead it's when t is 1, we get r is equal to minus 5i plus 2j. So we need to substitute that in. So r is minus 5i plus 2j, and that happens when t is equal to 1. So we get that in the I bracket. And over here we'll get 8 minus 1/4 in the j bracket, and then plus c. Okay, so tidying this up, this gives us 26i, and this gives us plus 7.75j. So minusing that, 26 to the other side gives us minus 31i, and then minusing 7.75 gives us minus 5.75j is equal to c. Okay, now let's write out the formula then for r. So just copying from this line up here, it's 27t minus t cubed, and then we've also got the I, which is minus 31 from the constant of integration. So those are all the i's grouped together, and then plus we've got 8t here, minus t to the 4 over 4, and then we've also got this here, which is minus 5.75 j, which comes from the c. Okay, so that's all nicely grouped together. So now we can answer the question which asks us to find the position vector when t is equal to 3. Okay, so all we need to do is just substitute in 3. So let's just try and do this as quick as possible. Minus 31. Okay, so 23i, and then we'll do 8 times 3, minus 3 to the 4 over 4, minus 5.75. That gives minus 2. Beautiful. And just a quick reminder though, I know some people like to do it in columns, but always make sure you give your answer in the same form that the question has given it in. So if they've given it in I's and J's, you should give your answer in I's and J's as well. Fine to work in columns, but then just convert back to I's and J's at the end if the question is in I's and J's. Okay, dynamics. And we have a particle of mass 2 kilograms. So I'm just going to put the information on the diagram as I read the question. So if it's got a mass of 2 kilograms, then it's going to be 2 times the gravitational force coming down. Whilst we're here, we might as well put on the components as well. So I draw a line down like so, and then a line across like so, like that. And this angle in here is always the same as the slope. So this here will be 2g cos alpha, and this here will be 2g sine alpha. It's cos because it's adjacent to the angle, and it's sine because it is opposite the angle there. Okay, so we've got a constant horizontal force of 30 newtons. So again, once I'm here, I'm just going to put in the components. So we can split it like so into perpendicular to the slope, and then also parallel to the slope, like so. The one parallel, again, this angle in here will be alpha, because it makes this kind of Z, like that. And then we're going to have this one is next to the angle, so that's 30 cos alpha, and then this one opposite is going to be 30 sine alpha. Okay, and it's on a rough plane, so we know there's going to be some frictional force depending on which way the object is moving, which we don't know just yet, so I'm not going to put the frictional force on. The plane is inclined to the horizontal at the angle of tan alpha is 3/4, so I'm just going to draw a quick little triangle here, put alpha there. So if tan is 3/4, it means the opposite over the adjacent is 3/4. This is a Pythagorean triple, so we know the hypotenuse is 5. So we can write that sine alpha is opposite over hypotenuse, and cos alpha is adjacent over hypotenuse. Okay, so it's all taking shape. Okay, now it says the line of action of the force lies in the vertical plane containing P, and the line of greatest slope. Okay, so that doesn't really mean anything useful for us. The particle P starts from rest, interesting. The coefficient of friction between P and the plane is mu. After 2 seconds, P has travelled a distance of this. Okay, so there's only a single force, or the forces aren't going to change here. So we've got constant acceleration, essentially. And we know that the distance travelled, we know the time taken, and we know the initial velocity. So with those 3 things, we should be able to work out the acceleration just by doing a simple SUVAT. Okay, so we do SUVAT. The acceleration is what we're looking for. T is 2, the initial velocity is 0, and the distance is 5.5. So the one without V is S is equal to UT plus a half AT squared. So 5.5 is equal to, now U is 0, so the UT is just 0. It's a half times by A times by time squared. So we get 5.5 is equal to 2A. So A is equal to 2.75 meters per second to the minus 2. Okay, nice. Now it says find the value of mu. Okay, so now we need to look at Newton's laws. and we need to equate some of these forces. Now, what I've not put on as well is the reaction force, which is going to be coming out of the object like so. So we'll put that on there, reaction force. And also, because the ball is moving up the slope, we know the frictional force is going to oppose that motion. So we can put the frictional force in coming like this, opposing the motion. We'll call that F. Okay, so we're just going to resolve now parallel and perpendicularly to the slope. So let's start off with perpendicular to the slope. Okay, so we have going up, we've got R, and then coming downwards, we've got this one, which is 30 sine alpha, and we've got this one, which is 2g cos alpha. Okay, so those are all the ones perpendicularly to the slope, and I think that's going to be enough for us to find R. Because all of these things are known. So we have 30. We said that sine alpha was 3/5 at the top there. And then we are doing plus 2 times 9.8 is G, times by cos alpha is 4/5. Okay, now that's going to be useful because that is going to help us out working out mu, because as we know the frictional force is equal to mu r. Okay, so the frictional force is equal to mu r. And now let's resolve parallel to the slope. Okay, so what have we got going on here? We've got coming down F and this 2g sine alpha, and going up we've got 30 cos alpha. Now they're not going to be balanced because the object is accelerating. So in fact what we'll do is we will show the way that it's accelerating, which is in this direction, up the slope, and we'll do an F equals ma for this motion. So going up will be 30 cos alpha, coming down will be the 2g sine alpha and the F. So the sum of the forces is equal to mass times acceleration, and we had 30 cos alpha going up, we had F coming down for friction, by the way, not the same F as in the sum of the forces, and then minus, the other one was 2g sine alpha, which was the weight, and that's equal to the mass, which is 2, times by the acceleration, which we know is 2.75. Okay, great. So now we can rearrange for the frictional force. So just doing some rearranging here, we could write this out like so, minus this one, and that should give us the frictional force. Okay, I could put that into my calculator, but in fact I'm not going to put it into my calculator yet, because I know that the frictional force is also equal to mu r. Like so. So mu r is equal to this. And we've been tasked to find mu. And we know what r is as well. We have that written down over there. So we just need to do this on our calculators and then divide it by r, which is 33.68. Okay, so let's do that then. So we do 30 times cos alpha was 4/5 minus 2 times 9.8. What on earth am I doing here? Didn't mean to do that. Minus 2 times 9.8 times by sine alpha was 3/5. And then minus 2 times 2.75. Okay, press equals and then divide that by 33.68. Lovely. Of course mu needs to be between 0 and 1, so I was very happy to see that number come out. And that looks like that could be the end of this question. Beautiful. Projectiles, and we have a object which is being projected from a position of 7j meters with a velocity of 21I plus 7j meters per second to the minus 1, as shown in the figure above. In the subsequent motion, the particle is moving freely under gravity. Okay, find the length of time for which p is at least 9.1 meters above the ground. Okay, so it's going to be going like this, and then obviously it's going to come back down. So there is going to be some time at which it's above this line, which is 9.1 meters from the ground. I don't know why I didn't finish off this motion. It's definitely going to hit the floor. Okay, so essentially the distance actually which we're concerned about is just 2.1 meters because that is how far it's going to change from its starting position in order to get above the 9.1 from the ground. So I just want to work out how long it will be, or what times it will be right here and right here. So we're going to look at the vertical because we're concerned about the vertical distance here. So we're going to write vertical, and then we're going to do an S, U, V, A, and T. Now the acceleration in the vertical is always minus 9.8 as long as you're making the positive direction going upwards, which I will do. This is going to be the positive direction. So therefore gravity is acting downwards, so the acceleration is minus 9.8. Now the initial velocity in the vertical was 7. That's because you see here the initial velocity says 7j, so in the vertical it's 7. And we want it to be 2.1 vertically from its starting point. So we're going to say this is equal to 2.1 displacement. And we're interested in the time. So we can tell v to do 1. And that means that we're going to be using s is equal to ut plus a half at squared. So 2.1 is equal to 7t. Half of minus 9.8 is minus 4.9 t squared. Bring it all over to one side. So 4.9 t squared minus 7t minus 2.1 is equal to 0. Plus 2.1, because we moved it all over to the left side. Be careful of that. And then we're just going to go to the equation, polynomial, degree 2, 4.9, minus 7, and 2.1. We're going to get 1, okay, great. And we're going to get 3 over 7. Okay, so t is equal to 3 over 7, and t is equal to 1. So 3 over 7 is less than 1, so that must be the first time that it goes. So right here, this is 3 over 7, and then this is 1. So the time that it's above 9.1 is the time in between 3 over 7 and 1. So the time we are looking for, so the time is going to be 1 minus 3 over 7, which is of course 4 over 7. We wouldn't really give time as a fraction, so we'll just literally give that as a decimal and then whack seconds on it, and we should be good to go. So 0.571 seconds. Perfect. Okay, so now it's over to part B, and it says that P is passing through the point with position vector 48i plus lambda j. So let's say that that is somewhere over here. So that is 48i plus an unknown j component. Okay, and so it says determine lambda. Right, so I mean what we know is we know the position of the horizontal. So we need to look at the horizontal to get some more information here. Okay, so what we're going to do is we're going to write horizontal, and we're going to do S, U, V, A, and T. Now, in the horizontal, there is no acceleration because the only force that acts on the object in this modelling scenario is gravity, so there's no horizontal forces. So it's always 0 for projectiles. And the initial velocity in the horizontal was 24I, I believe. And the displacement in the horizontal of the position which we are investigating is 48. So it would be useful to work out the time, because then we could work out how far vertically it has travelled at that time. So it looks like V is going to have to do one again. So this time S is equal to UT plus a half AT squared, but because the acceleration is 0, we just get 48 is equal to 24T, so T is equal to 2. So now we can look to the vertical again in order to work out the displacement of the object after this 2-second trip. So T is 2, the acceleration is minus 9.8 as we spoke about before, the initial speed in the vertical was 7, and we want to work out how far. So it looks like V has got to do one once again. So S is equal to UT plus a half AT squared is getting a real workout today. So 7 times 2 minus half of A T squared. So that'll be 2 squared. So we're going to do 7 times 2 minus 4.9 times 2 squared. Okay, so we get that S is equal to minus 5.6. So let's go and put that in context. What that means is that we started here and we have ended up actually at this point right here, whereby we have travelled 48 in the I, and we've travelled down by 5.6 from the original starting position. How actually far off the ground is this object? Because lambda here is relative to the ground, because this is the position vector. So what we've worked out is how far it's changed vertically relative to the starting position, but we need to actually work out how far it has travelled relative to the ground. So that is going to be whatever this distance is here. And again, we've started at 7, but we've come down by minus 5.6. So therefore, this is going to be 1.4 above the ground, because we've come down by 5.6 from 7. So our value for lambda is going to be 7 minus the 5.6, which is equal to 1.4 meters. Perfect. Okay, connected particles. We've got one end of a light extendable string is attached to a particle A of mass 5 m. So what I'll do is I'll draw the weight on there and label that 5m times by g. And I'll do the same over here and label this one 3mg. And then also we'll have tension, keeping these two objects up. And what that will do is that will allow us to work out an equation of motion for each of these two objects. So I know what some people like to do is like to draw a little kind of split here, and then let's also think about how this system is going to accelerate. So it's going to accelerate down on this side because we've got a larger mass here, and this side is going to accelerate up because we've got a lighter mass on that side. Okay, so drawing an equation of motion now, is going to be able to give us the acceleration and the tension, which is going to be useful because it's been asked to work out the magnitude of the force exerted on the pulley. Okay, let's then do an equation of motion for A first. And now in the direction of motion, so it's going downwards, we're going to have the sum of the forces is 5 mg is in the direction of motion, so I'll make that positive. Minus t is going against the motion, so I'll make that negative. And that's equal to, the sum of the forces is equal to the mass times by the acceleration. Okay, and now then for B. Again, in the direction of motion, we've got t going positive because the object is going to be going upwards, and then we've got minus 3 mg going down because that's against the motion, and that's equal to the mass multiplied by the acceleration. Now, if you've done it like this, we can always just add the two equations together, and the t's will cancel out, which is just always easy to make the simultaneous equations work straight away. So 5 mg minus 3 mg gives us 2 mg over there, and then here we're going to have 8 ma. So what we could do next is we could divide through, so we could do 2 mg over 8m, which gives us a quarter g. Okay, so now what we could do is we could work out the tension just by substituting back into one of these formulas. So the tension is equal to 3ma plus 3mg. So the tension is equal to 3ma plus g, which is equal to 3m 0.25g plus g, just swapping out the a for the acceleration, which is a quarter plus 1 is 5 over 4, times by 3m will be 15m over 4, times by g, of course. Okay, great, so that gives us the tension. Now the question asks us to find the force exerted on the pulley by the string. Okay, so if we just look at the pulley itself, initially what we've done is we've done a force diagram and we've looked at the forces acting on the two objects, the two masses. If we were to draw a force diagram looking at the forces acting on the pulley, we would have the string would be pushing the pulley down on both sides, like so. And that force will be the tension in the string, like that. So just looking now at the pulley, each side is going to be pushing down on the pulley. So the magnitude of that force is going to be not one but 2 lots of t, one for each side. So the answer is the force on the pulley is going to equal 2 lots of t, which is going to equal 2 lots of 15 mg over 4, which is going to equal 15 mg over 2. Okay, perfect. Now part B, it says state how in your solution to part A you have used the fact the pulley is smooth. Well, if the pulley is smooth, there's going to be no frictional forces acting around the pulley, and it also means that the tension of the string is going to be equal on both sides. Okay, so we can write here part B, we can say tension is the same on both sides of the pulley. Perfect. Okay, and to finish off, a lovely moments question. Okay, so let's put as much information on the diagram as we possibly can. We know the length of the ladder is 6 meters and has a mass of 20 kilograms. So at the halfway point, we're going to have the mass of the ladder acting. So the weight of that will be 20 multiplied by G for gravitational force. Okay, and then it's placed at its end A. Yep. So there's going to be a reactional force coming up here at A, like so. It's on rough horizontal ground, so naturally it's going to want to kind of slip outwards. So the frictional force is going to be acting this way, holding it up. And it says that it rests on a point at C, which is really important. So it's not actually hitting into the wall, it's resting on top of a point. And if that's the case, then the reactional force will be acting perpendicularly from the ladder, as opposed to if it was pushed up against the wall, the normal reaction will be coming outwards. But because it's actually resting on a point, it's going to be perpendicularly, is this reactional force, which we'll label N. Okay, and then it says that BC is 1, so that's 1 there, okay. Also, we know that the distance, from where the force of the ladder weight acts will be free, because it'll be halfway, because the weight always acts through the centre as long as it's uniform, which it says it is here, so that distance is free. And then it says that there's a man of 80 kilograms is standing at the point on the ladder such that AP is 4. Okay, so therefore it's going to be a bit further on than the centre, because that distance from there to there, let's call that just 1 now, because you've got 3 and 1, that makes 4. Okay, and that's 80 G in there. Okay, great. So what we're going to need to do is we need to do moments at A. Pretty much like 99% of all moments questions, you're going to want to do moments at A in order to knock out the reactional force and the frictional force, and then hopefully find the force we don't know, which is this normal reaction force. Okay, so what we need is we need the perpendicular components. So I'm going to draw an arrow coming out like this, perpendicular to that 20 G force, and that angle in there is always going to be the angle of the slope, which is going to be 60 degrees. So that component there is adjacent to the angle, so that's going to be 20 G cos of 60. And we're going to have the same thing coming out here as well, in exactly the same fashion. That angle is going to be 60. This is the weight of the man, which is going to be 80 G, and that's going to be cos of 60 again, because it is adjacent to the angle. Okay, great. So I think we're good to do moments now, because all the forces acting on the ladder are now, we've got the perpendicular component. So we can just go along the ladder. So that is a distance of 3 until we hit the first force. So we're going to do distance times by perpendicular force. So we're going to do 3 multiplied by 20 G cos 60. And then we're going to go along to find the next force, which will be a distance of 4 away, and then we're going to times that by the perpendicular force. Now those are acting in the same, what is that? It's going to be anti-clockwise or clockwise? No, I think that's anti-clockwise, but they're going in the same direction, so we can just add them together. So that's going to be 4 is the distance times by the perpendicular force. Perfect. Now that is going to balance perfectly with the other force, because the other force is going in the other direction. So we're going to go along to that. So the distance we're going to get there is going to be 5, because the whole rod is 6, and then a little bit at the end is 1. So that must be 5, and then we're just going to times that by the force, which is just n. So it's going to be 5n, and it's all balanced. So the anti-clockwise moments need to equal the clockwise moments. Okay, so it looks like this can all be solved. So I'm just going to put this into my calculator. Okay, right, I've put all of this long thing here, put that into my calculator, and then I've just divided it by 5 to get to the normal reaction is 372.4 newtons. I won't put an N there actually, it's just going to confuse things. Cause let's just leave it like that. Okay, lovely. But of course that's not the final answer. We need to work out mu. Now, you know, so many of these moments questions take the same form. You do moments at A, and then you have to resolve horizontally and vertically in order to find some missing forces. So, in order for me to do that, if I want to do the vertical and horizontal components, I need to split this normal reaction into its horizontal and vertical components, because at the moment it's just perpendicularly to the slope. So I'm going to draw a line up like so, and then I'm going to draw a line across as well, like this. Now, I always find the hardest part of this is actually working out what the angle is. So I'm going to hypothesize that this angle in here is 60, because I know that this is a right angle, because it's literally that's perpendicularly to the ladder, and I know this angle in here is 30 because this angle down here is 60, so this one must be 30 up here, and we've got 30, 90, and on a straight line that therefore must be 60. So I'm happy that that angle is 60. So now that allows me to take the components. So this one is N and it is opposite that 60 degree, so we use sine for when it's opposite the angle. And this orange one is adjacent to the angle, so we use cos when it's adjacent to the angle. Okay, so that allows us now to resolve the forces horizontally and vertically. So let's go with vertically first, for no apparent reason, but let's just do that. Okay, so vertically, what have we got? We've got this going up, we've got this going up, and we've got these coming down, and this coming down. Okay, so let's put this all together then. So R plus, it was N cos 60, are the ones going up, is equal to, is equal to, it was 20g was the weight of the ladder, and 80g was the weight of the person. Okay, great. So that means we can solve for R because we know N and we know everything here. So we can just put this into our calculator to solve for R. Okay, I've done that. Just rearranged that equation and I've solved for R to get this. Okay, now, I mean, ultimately we are trying to find mu, so ideally what we're going to want to find is the frictional force, because of course we know that friction is equal to mu R, but we've got R now, so that's going to be really helpful. Okay, so we know, of course, that friction is equal to mu R when the object is in limiting equilibrium, like it says it is here. Okay, so now what we're going to do is we're just going to look at the horizontal. So we've got N sine 60 going that way, and we've got F going that way, and those are the only horizontal forces. Okay, so they must be balanced. So we can say that F is equal to N sine 60. And we know what N is. It's 372.5.4, and we're going to times that by sine of 60. Great, so we're going to get 322.5. So to finish it all off now, we're going to use this formula here, and we're going to say that mu is equal to F over R, which is going to be this guy here over this guy here. So we're just going to divide that by 793.8, and we are going to get a final answer of 0.4 0.06. Right, I hope you enjoyed that. If you did, and if you enjoy watching me going through questions, then I suggest you sign up to my live revision session, which is happening this Sunday. And if you miss it because it's sold out or because you're watching this post Sunday, then you can purchase a copy of the recording with all of my video solutions and work solutions instantly. And yeah, it supports your learning and supports me in what I'm doing. Win-win. Can't say fairer than that. Okay, good luck in your exams. Bye for now.